Hello students, today we will see the next topic is carrier sends multiple access, that means CSMA. With slotted aloha, the best channel utilization that can be achieved in is 37% only. This is surprising. The stations are transmitting the data without paying attention to what the other stations are doing, and they are bound to many collisions. Here, in LAN, it is possible for stations to detect what other stations are doing and adopt their behavior accordingly. And this network can achieve a much better utilization than slotted ALOA. To minimize uh, the chance of the collision and increase the performance, the CSMA method was developed. The chance of collision can be reduced if the station sends medium before trying to use it. And the protocols in which the stations listen for the carrier and act accordingly are called as the carrier sends protocol. Here the CSMA is a network access method used on the shared network topology such as the Ethernet to control the access to the network. Then devices attached to the network cable listener, that means the carrier sends before transmitting if the channel is in use, and devices wait before transmitting. MS stands for the multiple access, which indicates that many devices can connect to and share the same network. All devices have equal access to use the network when it is clear. Even though devices attempt to sense whether the network is in use, and there is a good chance to two stations will attempt access it at the same time. On large network, the transmission time between one end and the end of the cable and another is enough that one station may access the cable even though another has already just accessed it. And the chance of collision still exists because of the propagation delay, and the frame transmitted by one station takes some time to reach other stations, and in meantime the other stations may sense the channel to be ideal and transmit their frames, and this result in the collisions as shown in this figure. See, this is the figure area where the first signal exist, then area where the both signal exist. Here this is the first signal, that means the A signal exist, and here the second at the time t1, that means the B starts at time t1. This is the area where A signal exists. Then here the C, that means the third start at time t2, and here the t2, and here this is the area where the B signal exists. This is the time and space model of collision in CSMA. Then vulnerable time. The vulnerable time of the CSMA is the propagation time TP1, and it needed for the signal to propagate from one end of the medium to the other, and when the station send a frame and other stations tries to send, then collision also occur. But if the first bit of the frame reaches the end of the medium, then other stations will already have heard the bit and will stop ourselves from the sending. Here the senses vulnerable time is equal to propagation time, and here the first, second, third, fourth, that means A, B, C, D, and here the second sense, that means B sense here, here the C senses here, and D senses here. Here the vulnerable time is equal to propagation time, and this is the frame propagation time. Then the persistent method. There are the three types of the CSMA protocol. First one is the these are the first persistence CSMA, then the non-persistent CSMA, and third one is the p-persistent CSMA. First one is the first persistence CSMA. This method is very simple and straightforward. In one persistence, that means first persistent CSMA method, stations that want to transmit data continuously senses the channel to check whether channel is ideal or busy. If the channel is busy, then stations wait until it becomes ideal. Then when the station detects an ideal channel, it immediately transmits the frame with probability 1. Then hence it is called as the one persistent CSMA. Then this method has the highest chance of the collision because two or more stations may find channel to be ideal at the same time and transmit their frames. When the collision occurs, the stations wait at the random amount of time and start all over again. But here the drawback of first persistent CSMA, the propagation delay time greatly affect this protocol. Suppose just after the stations first begin its transmission and stations 2 also become ready to send its data and sends the channel. If the station 1 signal has not yet reached station 2 and stations 2 will be sends the channel to be ideal and will begin its transmission, and this result will be collision, result in collision. Here the continuously some senses, that means here the busy and sense and transmit. Here the a persistent one persistence and second one is the stations can transmit. Here the channel ideal or busy, this is the structures for the stations can transmit one persistent CSMA. Even if propagation delay time is 0, then collision will be still occur. If the two stations become ready in the middle of the third station's transmission, then both stations will wait until the transmission of the first station end, and then both will begin their transmission exactly simultaneously. Then this will also result in collision. Then second type is non-persistent CSMA. In non-persistent CSMA, or stations that has a frame to send senses the channel, and if the channel is ideal, it send immediately. If the channel is busy, it wait for a random amount of time and then sends the channel again. In non-persistent CSMA, the station does not continuously send the channel for the purpose of capturing it when it detects the end of previous transmission. Then advantages, it reduces the chance of collision because the stations wait a random amount of time. And the second one is, it is unlikely that two or more stations will wait for same amount of time and will retransmit at the same time. Then disadvantages for non-persistent CSMA, it reduces the efficiency of network because the channel remains ideal when there may be stations with frames to send, and this is due to the fact that stations wait the random amount of time after the collisions. Here see, this is the figure for the non-persistent CSMA. First one is that their busy channels and it wait for some senses and sense and transmit. This is the ideal channel. And here the channels check here the busy or ideal and it wait for randomly. Then third type is p persistent CSMA. This method is used when channel has time slot such as the time slot duration is equal to or greater than the maximum propagation delay time. Whenever a stations become ready to send, it sends the channel, and if the channel is busy, stations wait until the next slot. And if the channel is ideal, then it transmit with the probability p. That's why with the probability q is equal to 1 minus p, the stations then wait for beginning of the next time slot. If the next slot is also ideal, then it either transmit or wait again with probability p and q, and this process is repeatedly till either frame has been transmitted or another stations has been begun transmitted. In case of the transmissions by another stations, the stations act as the collision has occurred and it wait random amount of time and start also again. Here the channels continuously senses in the busy channels, then here the probability outcome does not allow the transmission. Here the time slots and transmissions. Here first we'll check the channels ideal or busy. When the here channels is busy, then it will be repeated. Then ideal, it probability outcomes greater than or less than p. Here the p persistent CSMA.